Okay, so I'm not trying to trick you. What would we do first on the top one? 7 times 4 times 3 times 1/2. So if we were doing this in pieces, we would do that because this is multiplication first. So on the bottom one, can I take all these numbers and smash them together? No. Then why did a third of you do that? Okay, so a lot of us took this and made it like it was different numbers. But it was like 10,000 and 2,500 minus, like, I don't know, what is it? 5,000. Something like this, cosine of 20. And you guys would smash all these together to get like 5,000. Cosine of 20. No. Order of operations still holds. We cannot do all of this first. No, we do not. We can do this, but we cannot then combine these together.
So we did a bad job?
So order of operations says this chunk sticks together. This is multiplication. This is 10,000 times cosine of 20. I cannot do addition and subtraction before I do my multiplication.
So are you gonna let us retake it? Or?
I mean, like that was like 1 point out of the 20. So like, scores just went in like 2 minutes ago. Order of operations still holds even though it's trig. So we got to do our multiplication. We can get it here and then type this in the calculator. We can type this in the calculator. We just can't take all these coefficients and play with them and ignore the fact that it's times cosine.
So wait, if you just put in the calculator like
Just like that, whole thing across. It's fine.
Oh.
But it's when we simplify these separately and make this into like 2 cosine of 20 or 4 cosine of 20. I had a lot of people add together these coefficients. These two are fine because they're not being multiplied. But once we start trying to grab this guy over here and mix him into the mess, then it's a whole lot of. Okay? So, order of operations still holds, even in trig. That was my little rant, just because I finished grading them all of 5 minutes ago. Okay? We are still doing stuff. Like, no joke, they're still like sitting on top of my notebook for today. So there we go. So we're still moving on. We're still going to do stuff. We're going to talk more about vectors. And today we're going to talk about two very special kinds, or one very special kind of vector. It's called a unit vector. And what a unit vector is it has a magnitude of 1. So if we go through to find our magnitude where we do our square root of x squared plus y squared, we would have an answer of 1. So this one here, 4/5, 3/5, that is a unit vector because it has a magnitude of 1. Unit vectors actually will land on the unit circle. That's why it's a unit vector, unit circle. It has a radius of 1. I'm going to look at my stylus. So good that. We have two very special unit vectors. They're identity vectors. And it's I and J. And those names are locked in. They are called I and they are called J. And we will use I and J for things. And all I and J are, if we think about them, and we were to think about like maybe sketching them. Oop, hang on, let me make that so you don't have to follow my brain. There we go. I has an x value of 1 and a y value of 0. So it just is my x-axis. Oh, sorry, that's right on the mouse. That guy. Come on. trying to get that mouse to move, but it's being annoying. And my j vector has no x and is just up 1. So it's my x-axis and my y-axis. And what we're going to do is we're going to start looking at vectors as combinations of how many steps to the right, how many steps up. That's what we mean when we say a product of unit vectors. I is 1 step to the right, j is 1 step up. And we're going to see how many times we combine them together to make other vectors. So we're going to start with some things we've done before. We're going to find our component form for these 2 points here. To find our component form of vector AB. What's up?
Let's tell them what the test is.
Okay.
Math.
I'm sorry, there was a bunch of so math.
Yeah,
So math, much mathing.
Take the lowest quiz out, right? For test.
The lowest quiz will drop at the end of the semester, yes.
Okay.
But like if you do good on the final, it's like the lowest test.
The final exam can replace the lowest test score if you do better on the final exam than you did on a test. Okay. So let's start with finding our component form. That's when we're finding the change in our x and the change in our y. So the change in my x, I'm going to do my 2 minus -6. And I'll do my change in y's, 5 minus 0. So what is my component form for vector AB? 8, 5. So if I was to try and sketch this out, we know it would start at my unit circle, or my origin, that's the word I was looking for there, goodness, and it would hit the point 8, 5 as our terminal point. If I write this in terms of steps right and steps up, so in terms of steps right and steps up, how many steps right did we go? 8. So we took 8 I steps. So 8 right steps. How many up steps did we go? 5 J steps. That is what we mean as a linear combination of unit vectors. How many right, how many up? It's weird. And it doesn't feel like it's super helpful for very much, except it showed up on the final 2 years ago. Not last year, but 2 years ago. So I'm hitting it. Questions on that? That's what we're doing with them. All right, we're gonna try it again. And then we're gonna play with our vectors a little bit. All right, so again, we're gonna find our component form for vector AB. So we do our angle bracket, and we're gonna find the change in our x's. So what are we gonna do? What do we do next? -8 minus 4. And -5 minus -1. If the double negatives bother you, you don't have to write them. You can do it as a plus. Totally fine. So our component form is what? -12. I heard debate on this one. -4. There we go. So that is our component form. To write it as our product of unit vectors or as the linear combination of unit vectors, it gets written both ways. So that's why I have both wordings up here. How many I vectors do we have, or how many I steps do we have? 12, but are they negative 12 I vectors and negative 4j vectors, or negative 12I minus 4j? The I needs to go with the x, and the j needs to go with the y, but as far as if I put negative 4j minus 12I, that doesn't matter. But the I needs to go with your x term, and the j needs to go with your y term. So from this, we're actually going to take vectors that aren't unit vectors and start kind of playing with them and smushing them together. So we're going to look at some operations on vectors. So we're going to have two vectors here. We're going to have vector A, which we have terms A1 and A2. That's still my X and my Y. I'm just labeling them A so we can talk about what the heck we do with these things. Bless you. And vector B, I'm using B terms here. So the word scalar is coming back into play here. Scalar is a multiplication on a vector. My goodness.
Sorry.
Bless you. You okay?
Yeah.
There's hand sanitizer on my desk and by the turnip bin if you need it. That was intense. All right, so if I take a number times my vector, all we're going to do is we're going to take each of the terms inside, my x term, and multiply it by that same constant, and my y term, and multiply it by that same constant. So for example, if I wanted to do, let's say 3 times the vector, I'm making this up right now, 1 comma 2. We would take 3 times each of those pieces and get the vector 3 comma 6. We're multiplying each of the pieces. It feels like distributing, yeah. And addition and subtraction, it looks super obnoxious down here. If we're adding two vectors together, we add the x's, we add the y's. If we're subtracting two vectors from each other, we subtract the x's, we subtract the y's. It's not super complicated except for the fact that it's vectors and those are scary. So it's written out here and it looks super duper complicated and calculatory. But they're not. And these two pieces down here should have arrows at top. These are vectors. And we are going to practice doing all of these. And we have 10 minutes, which is plenty of time. Sweet. That gets us in the place I want us to be. Awesome. Give you another minute to write these down. I feel like writing down this might actually make it harder, but I'm giving you the things behind it because I know you guys like formula kind of things. Because I'm going to give you 3 vectors that we're going to perform operations on. And that'll be our last page for the day. Because no, we have until 08.
Oh, it says 8. That's a 3.
That's an 8. My handwriting is not that bad. All right. So I'm giving you 3 vectors here. We have W as vector negative 4, 1. We have Y as vector 2, 5. And we have Z as vector negative 3, 0. And what we're going to do is we're going to do these operations. And we're going to start with 4W plus Z, because that includes an addition and a scalar multiplication. So just like order of operations still holds in trig stuff, order of operations still holds in vector stuff. So we're going to start with our what on this first one? The 4W. So we need to take 4 times our vector for W, which is negative 4, 1. And then we're going to add on Z, and I'm just going to write it down here. Our negative 3. Yeah, if you need to for a second. So I'm starting here with just substituting my vectors in place of the names. Then we're going to do our multiplication. We're going to take our 4 times vector W. So 4 times negative 4 is negative 16. And 4 times 1 is 4. And we're then going to add to that negative 3, 0. So we're going to add our x's and we're going to add our y's. So that's going to give us negative 16 plus negative 3 and 4 plus 0. So what is our final answer here in component form? Negative 19, 4. If we wanted to express that as a combination of unit vectors, using our I and our J, guys, negative 19I plus 4J, or 4J minus 19I. And that's our answer. We were asked to express it 2 ways. We gave it 2 ways. Those were our 2 ways. Let's do our next one. This one's just a scalar. So we're going to have our negative 3 times our vector W. Our W is negative 4, 1. So what is our answer going to be? What is negative 3 times negative 4? That's positive 12. Negative 3. We're multiplying it. We multiply our scalar by our x and our y. So again, expressing that in terms of unit vectors, using our I and j again. 12I minus 3j. Like I said, once we get the hang of these, they don't suck. All right, last one, and this will be the last one for the day. We've got 2w plus 4y minus z. Lots of pieces here. I'm going to start with just doing my substitution. So I'm going to have my 2 times my w, which is negative 4, 1. We're going to add to that 4 times y being 2, 5. And then we're going to subtract our z. It doesn't get a scalar. Negative 3, 0. I usually start by just writing it all out like this. If you want to do the multiplication in your first step, I am okay with that. Totally fine. I understand that we probably can multiply 2 times negative 4 in our heads, and that we don't necessarily need to write that down. Because what we're going to have, once I do all of my multiplications, 2 times -4, -8, 2 times 1 is 2. Then we're going to be adding to that 4 times 2, which is 8, and 4 times 5, which is 20. And then we're subtracting, and this one didn't get a scalar, so he's just coming down. Then let's get this combined together. So we're going to take all of our x values and combine them together. We're going to have our -8 plus 8 minus -3. And our y's are going to be 2 plus 20 minus 0. So what is our answer going to be when we start combining together our -8 plus 8 minus -3? We're going to have 3, comma, 22.
Teachers at this time, please release students to
No!
their assigned area.
It's 2 minutes early!
Their assigned
My sophomores, you need to get a pass for the thing. There's only 4 of you.
speaker and presentation period will end at 10:02. 9:15. 10:02. Please send students to their assigned areas. Thank you.
Juniors go to the gyms. Seniors go to the Performing Arts Center. Sophomores go to the place I'm posted out. Don't change the times on me. He gave me times and then changed them. We still got through what I needed to get through, but still. Rah! Writing it down so that I can then post it, because that's exactly what we did. We got there.